welcome guys. So keep solving our physics subject GRE. So 78, one isolator of mass m. Basically the question is too long that you can read it by yourself. So basically, you will when they stick to this object, then they will start to rotate and ask about velocity. When the staker initial at y equal b equals to b, y equals to b over 2. So ask about this one, their velocity corresponding to t. Okay, so the velocity need to be continuous. So we know that dx over dt at t equals to 0 is 2v. So this is the sufficient, the necessary condition what we need to have. And remember, a is impossible because we know that they should start rotate. So a is impossible. So the remaining is b, c, d, e. Okay. So all we need to is calculate which one satisfies this condition as our necessary condition. Okay. So for b, dx dt is equals to v plus times b over 3v cosine 3v t over b. And the c is similar. D is similar, is like the ds of dt is v plus half b 6v over b cosine 6vt over b. Dx dt is half v plus half b 6 over b cosine 6vt over b. When t equals to 0, this one is v plus, so bb cancel is 1 point v, which is 2 point v, 5v, and then this is 2v. This is v plus 3v is 4v. This is 0.5v plus 3v is 3.v, 5v. So the remaining is, the correct answer is C. Correct answer is C. So it's very nice way to solve this question. 79, basically you have omega versus k. And then the important formula you need to remember is v equals omega divided by k. This is called the phase velocity, and d omega over dk. This is called the group velocity. This is just definition. Okay. So you see, Vp is greater than 1. Is greater than 0 because omega is larger than omega and k are positive. But Vg in the this region, the slope is negative. So the answer is that A. They are in opposite directions. One is positive, one is negative. And the B is not correct, C is not correct. D said that the phase velocity is infinite, which is finite. So the E makes no sense. So the answer is A. Okay, so AT. A beam of electron is accelerated through the potential difference of 25 kilovolts in an X-ray tube. The continuous X-ray spectrum emitted by a target of the tube will have a short wavelength limit, mostly near the. Okay. So we want to solve number 80. So basically you have electron volts. So the remaining is that we want to somehow connecting the electron volts. We somehow connected the electron volts to the wavelength. So we have this energy is h times frequency, basically hc divided by lambda. So lambda is hc over E. Okay, so we have h is 4 times 15. This is EV times, and times 3 times 10 to the 8, and divided by energy is this one. So which is Armstrong, 0.4 Armstrong. Direct computation. So we should choose B, 0.5 Armstrong, 0.5 Armstrong. Okay, I think it's enough for today, and I will see you guys in the next video, and be sure to subscribe to my channel. Thank you.